Yeah. So yeah, hi Professor, I'm Nat and I'm a chemistry major student and this is my senior project which is about the synthesizing of the sulfonated surfactant which is looking like this. Let me show you. Yeah, it's have the formula like this. The formulas have the two benzene ring and have the azo coupling, the NN double bonds over here. On one of the benzene ring, there's a sulfonated, and another on another benzene ring, there's a long chain carbon connecting to the amino group. So I think I make a mistake because I mean like I'm trying to do it like vertically, but when I show you, I think it's kind of hard to read the text, right? Yes. Yeah. So so do you prefer me to do it like this, or you want me to keep the PowerPoint like this for you to easier to read the
Yeah, I
test?
don't mind you
Okay, okay,
moving
okay.
it so I can see it.
Got you, got you. All right. So yeah, so we decide to break the synthesizers into two steps. The first step, we're gonna make the long chain carbon attaching to the benzene rings. We call it the N-decoaniline. And what we make at first, we dissolve the 1-bromodecane with an excess of aniline and reflux it at 80 degrees for 36 hours. Then we wash the solution with 100 ml of 5% sodium hydroxide, hexane, as a loss of the eye water, trying to remove all the excess amount of aniline in the solution. Then we perform the rotary evaporate, and finally we did the column chromatography, trying to trap all the aniline on the top of the silica, and we collect all our endocoaniline over here. And in order to test the purify of the stuff that we make, the endocoaniline, we perform the IR, the NMR, and the TCL. So in the IR, as you can see, the formulas over here, we have the amino group, which is about 3409. This is the signal of the amino, the NH stretching. All the peak from 300 to 3850. That's the peak for the CH3, CH2 stretching. And we also found the peak around 1600 to like 1400 over here. Those are the peak for the CC conjugated system. In the IR, there's the most upfielded, there's a signal of the hydrogen from the CH3 carbon, which is over here. And all the peaks over here, those are a signal for the hydrogen in one of these CH2 carbon, and the small peak right over here, that's the hydrogen belonging to the amino group. All the hydrogen from the benzene ring, we found it the most is downfield, which is over here. And for the TCL at the end, like that's a caterpillar stuff. At first, well, after the reflux, there's still the excess aniline in our solution. So you can see there's a little dark spot right over here. Those are the signal of the aniline. And at the end, when we finish the column chromatography, we collect our solution, which is very pure. That look exactly like the reference that we got. So we are ready to move on to the next step. And I'm planning to continue the research with Dr. Joes and maybe on summer and probably on the fall semester as well.
That
Do
is
you have any?
great. That is very good. Let me
Thank you.
ask you,
Yeah.
go up to that second, not the IR, this one, the middle one right there. Tell me
Yeah.
the machine again. Is that mass spec?
No, no, no. This is we call it the carbon NMR. The name
Oh,
of which,
NMR. Okay, NMR. Yeah, I didn't remember what you had said there. Okay, very nice.
yeah. So let me.
Now, when you continue the research, so what else are you going to do?
Yeah. So in the future work, we're gonna do some of the sulfonated stuff like Dr. Cho say we can purchase this substance online, but like we're gonna do some of the synthesizing, trying to make the hydrogen become like releasing from the aminos over here, trying to get the sulfonated, and at the end we will combine the product we got, which is the aniline, the long chain
Hmm.
carbon aniline, with the um with with the azo with the substance over here, trying to make the azo coupling, the anion double bond, and to get our final product. There's a potential that we can do like an ionic polymerization because we have the negative oxygens over here, so we can properly we can do it.
Okay, very nice. And then in terms of uh, utilizing what you develop,
Mhm.
right?
Yeah.
Tell me what 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 will we yield from that? I mean, potentially.
Yeah, so the purpose of it, we are making the sulfonated surfactant, and the surfactant we have many like application like because of we reduce the surface tension
Oh
between
yeah,
the liquid, a gas and a liquid, or a liquid and a solid. So there are many application for it. Like we can do like we can apply it into the water and oil emulsion, or like the wetting agent, detergent, foaming agent, or like dispersion as well. Yeah, many application for that.
excellent. Thank you so much. Good
Mhm.
luck.
Thank you so much.
Okay, keep your recording. You can turn it off now.
Oh, okay, okay.
All right. And let's see. I think the session now ends and you are free to go into other people's sessions, session 2.
Mhm. Yeah,
Okay.
yeah, yeah. I'm gonna go
Thank
to
you.
one of my friends.
All right.
Yeah, see
Thanks
you
so much.
then. Yeah,